Let's look at this problem here. An example. A car weighs 3,000 pounds. You know that in physics. You measure weight in newtons, right? But we're just using the imperial measurement for now. It's kind of more, what they call it again, intuitive. And you know your weight in pound. Even though sometimes they say you weigh how much kilogram, it's really mass. But the thing is, you have a car weight 3,000 pounds. It's parked in a driveway that is inclined at 15 degrees to the horizontal. You must find the magnitude of the force required to prevent the car from rolling down the driveway, and also find the magnitude of the force experienced by the driveway. I guess it would be the magnitude of it at right angle to the surface, right? By the driveway due to the weight of the car. Alright, so we see if we can get a little representation of what you're supposed to do. Let us say we have our car, and this is my car. Alright, 3,000 pounds. Straight down. Good. But what if that happen? It is tilted at 15 degrees now. So my car again. I park on the driveway and I have to pull up my parking brake. So you have it tilted at 15 degrees. So you have a tilt here, 15 degrees. But the thing now is this. Oh, that 3,000 pounds, you know, goes straight down, right? Now the thing is, if you take this 3,000 pounds out here, we're going to compare it in both situations. This 3,000 pounds is going straight down, right? But now, if we keep this 3,000 pounds as it is, this is the end of the 3,000 pounds. What we're going to do, if we tilt this 15 degrees, we'd have to also tilt 15 degrees. So guess what? You see? We would have to have a situation here where, since we cannot change the magnitude of this 3,000 pounds, we have a situation here where we have the magnitude on the surface of the driveway would get short, and we have this magnitude of a certain force would be similar to this. So you have a certain component of this vector. This component prevents roll, R-O-L-L, rollback. That is a component that would prevent rollback. And this angle would be 15, right? Remember, we have a 15 degree here. If this is tilted at 15, this would also be 15 degrees, all right? You see that? Now notice, if we had a case where the driveway was like this and the car like this, the force preventing it from rolling back would be 3,000 pounds, and the force on the driveway would be 0. All right. Here, the force preventing it from rolling back would be 0. The rollback force would be 0, and the force on the driveway is 3,000 pounds. But here now, you're going between those forces. So here, you have this force. Remember, the 3,000 pounds is going down. So the 3,000 pounds would be this force, 90 degrees to the surface, plus this force, the triangular again. You see that? So we're going to do some calculation. What we have is really a right angle triangle, where this is 3,000, this is 15 degrees. Let me see now. Cos is cos, sine. Sine 15 degrees is the opposite. This would be the opposite of 15 degrees. Call it OPP if you want, over hypotenuse 3,000. So the opposite would be 3,000 sine 15. Alright, so 3,000 sine 15. Calculator. Now, we get to our calculator and see what happened. So, clear calculator, 3,000 times the sine of 15 degrees. And by the way, is it degree? Angle in degree. Good. A 15 degree equal 776 pounds. Equals 776 pounds. Alright. So, the component, what? This is 776 pounds. The component now that will prevent, but that would be experienced by the surface of the thing here, the driveway, would be what? It would be cos in this case, you know. So let's call it, or I want to call it now, since this is surface, call it surface. Surface. All right. So the surface force on the force on the surface. How you calculate that now? Sine or cos, use cos. Let me erase this. Equals sine. We just call it surface. Now, cos 15 is equal to adjacent surface over the hypotenuse 3,000. So the surface force will be 3,000 cos 15 equal 3,000 cos 15 would be what? Calculator. $3,000 times cos 15 equal 28.98. 28.98 pounds. So this is 28.98 pounds. All right. So that's what you have there.